Okay, so hopefully you've all got the number or the QR code there, and I will fire up Rhino. I hope. I will do this on my underpowered laptop so that we can really put everything to the test. So I'll leave that going in the background. Here we go. Import. We're going to import our lovely people so we know how big a person is. There we are. And I'm going to adjust my view so I can see these people. In order to make a super simple staircase, I'm going to use all 4 of my viewports for this particular task, because what I need to do is let's just start with a super simple straight staircase. So I know that I might just hide these people so they're not taking up too much room. A really useful thing to do is, if you're trying to build a staircase, is to go and measure a real one so that you know kind of how big things are. Everything that I've shown you so far, there's been a kind of freedom in the way that I tend to model things. I kind of tend to do things a little bit by eye and then correct them later. With staircases, there's a kind of set number of dimensions that you know are going to have to be correct. So this is going to hopefully sort of switch your brains into the idea that you can use Rhino to not just be quite free in the way that you model, but be very, very accurate as well. So what I'm actually going to do is I'm going to start off with complete control over exactly where I want the construction lines to go in constructing this staircase. The way I'm going to do it is I'm going to start with a set of lines or curves or polylines, however you want. I mean, they're all kind of the same thing. I'll start with just polylines because that's the kind of easiest way of doing it. And what I want is to know exactly how long those lines are and exactly where they start and where they end. So we're kind of moving into this realm of Rhino modeling, which is not just, oh, I'll just grab a tool and just kind of go, hey, let's draw a curve. Oh, it can go anywhere. Hey, this is great fun. But this is actually, I really want this to go in exactly this particular place. I want it to be exactly this long, or whatever. So the first thing I can do is I can draw a line by typing line. And hopefully you're sort of happy with this so far. And what we used to do is sort of having this crosshair, and I can place my mouse anywhere I want. However, if I wanted to, I could type in a coordinate at this point. I could say, I want this line to start at, and if I could pick 0 or 0,0. And if you think back to your GCSE maths, where you had to draw graphs along the corridor and up the stairs. Do you remember doing that? Yeah. You had the x-axis and the y-axis, and the first number of a coordinate system is the x-axis, and then the second number is up the stairs, up the y-axis. And Rhino has exactly the same coordinate system. In fact, it has a 3-dimensional coordinate system. If I really wanted to do, I could do 0, 0, 0. And that means 0 on the x-axis, 0 on the y-axis, and 0 on the z-axis. And you'll see that my mouse has now lost the middle bit of its target, because I've typed in a number, 0, 0, 0, and now that point is being highlighted in my window here. That's the middle of my Rhino file, 0, 0, 0. Now, what if I knew that I wanted my staircase to start at 1000 on the x-axis and then 0 on the y-axis and 0 on the z-axis. Well, I could type 1,000, and that would put my point exactly 1 meter away on the x-axis. Do you see where I'm going with this? Basically, I'm not clicking anymore, I'm typing numbers. You might think, well, that's pretty slow and boring. But it's going to speed us up when it comes to later on. Let's start at, in the middle of the file, start at 0, 0, 0. Press enter. And now it asks me to put my next point in for this line. And clearly, for a staircase, the first thing that happens when you walk up to a staircase is you see a stair that goes up, right? From the floor. So I know I'm going to have to draw this line that goes up into the sky. And what most people do is they kind of come into this viewport and they're like, why can't I get my mouse to go up? Whenever I can't drag it up, it ends up being like sitting on the ground like this. Have you come across this frustration when you've been modeling before? Like, but I want to go up. Let me go up, please. And it doesn't let you. It's basically always flattened along the floor. Well, this is why you've got 4 viewports. So what I can do is come over to my front viewport here, and I can drag my mouse up here, and then I've got up and down control. So I can drag my mouse. I'm not holding down any buttons. I'm just dragging my mouse from this view to this view, and now I'm in up and down world. Up, down, left, right world. However, what you'll notice is that as I move up and down and left and right, look at the top viewport. I can only go in that plane. So what view I'm in has a huge impact on the construction plane that I'm working in, and I have to choose a view that's going to make most sense to me. So for me, drawing this staircase, I'm going to come into the front view, and I want to go, well, how tall is a stair? Does anyone want to... no one's got a tape measure with them, have they? I think probably you're going to find it's about 150 millimeters tall, something like that, standard stair. And if you weren't sure, then we could always Google it. Standard stair size UK. Here we go. 150 tall, 220 going. The rise and the going is what they call it, and you'll probably cover this a lot in your technical classes. So we're going to go up 150. So I could type in 150, and now my command has changed. I've got this white area, which is basically telling me the direction. And then if I zoom in here, you will see that this line has a black part of it that is 150 millimeters wide. So I've typed in where I've started the line and exactly how long I want it to be. And Rhino is asking me, well, where do you want the next point to go? Which direction do you want to go in? Well, I want to go straight up, so I'm going to hold down Shift, and that constrains my mouse to going in one of the 4 kind of compass point directions. And then I can click anywhere along this direction. And it will give me a line that starts at the middle of the file and is exactly 150 millimeters tall. Are you following me so far? Happy with everything I've just done? Cool. I'm going to take a little bit of time to get the first one right, because now I can do another line, and I can start at the top of this one. And if I've got my O snaps on and I'm snapping to the end of the line, I can snap there. And then I want to go across. And in fact, because I've got Smart Track turned on, it's kind of worked out that maybe you want to go in that direction. And it was 210 millimeters, or 220, call it 220. Nice generous stair, 220 mil. And I've clicked the first point, I've typed in exactly how long I want that line to be, and it's given me exactly the same thing here, which is the black part of the line is 220 millimeters long. The white part is just telling me the direction I'm going in. I don't actually have to drag the mouse further than the line. I could drag it just a little bit less. And then I click. And now I've got this. And this is the outline of the first stair. Now, what I'm going to do now is I'm going to say, well, I know I have to go from a floor that is a certain height above the ground to a floor that is another height above the ground, and I can just do a quick calculation to work out how many meters that is. Now, standard distance between floor to floor might be something like, I don't know, 3,000 millimeters, 3 meters, something like that. So I can grab a calculator and go, how many stairs do I need? If each stair is 150 millimeters, and I need to travel 3,000 millimeters, well, it's pretty simple. I just take 3,000, I divide it by 15. You could do that on a calculator. You could also do calculations inside Rhino when you're sorting stuff out. So what we can do is I can draw a line that basically is like a helpful construction line. I'm going to start it at 0, 0, 3,000. And then I'm going to come up here, whoop. And this is going to represent just a sort of like helpful guide for where my first floor is going to be. Yeah? It's just basically a line floating in the sky, just to help me understand where my staircase needs to end up. It doesn't have to be even in the right place. I just know that there's a line there that is exactly 3,000 above the ground. The other thing I could have done is drawn it on the floor and then moved it up exactly 3,000 millimeters. But might as well just draw it in the right place to begin with. And now what I'm going to do is I'm going to take this guy here and I'm going to join those lines together. So now these two lines have become polylines that are joined and they're one object. That's like one stair, effectively. The cool thing is I can now say I want to array that little line. I want copies of it and I want a certain number of copies of it in a particular direction. And there's a command that I can do that with. It's called array linear. If I type array linear, can you all see that on the screen? It's quite small, quite a long way away. Is that roughly readable? Cool. This is also recorded on the screen, so you can come back and zoom in later. And it says number of items, currently 2. Well, I don't want 2 stairs. I want however many stairs I need to get from 0 to 3,000. And I know each stair is 150. So what I can do is I can type 3,000 divided by 150. And the answer is that many stairs. And check it out. The last stair hits exactly right. So I haven't even had to do the calculation. I've just said, oh, well, Rhino, you work it out. You work out what 3,000 divided by 150 is. And then the answer is clearly 20. Or whatever it is. How many there are? 20 curves. Yes, exactly 20. And that makes sense, because 150 into 3,000 goes 20 times. Now, in reality, we tend not to have 20 stairs in a row. Anyone know why we don't have 20 stairs just in a whole row? When you go up the stairs in this entranceway, obviously we are going up 3 meters, but what happens halfway along the staircase? Yeah? You get tired. Yeah, absolutely. Especially if you're maybe a little bit older, or you're very young, or you find walking very difficult, or you have a broken leg. You get tired after walking 10 steps. So what we tend to do is we give people a little break. We have a landing where they can just stand, they've got a nice bit of space, they can wait, they can rest, and then they carry on, and they'll hold the handrail or whatever. So what we can do here is I can select these top 10 curves, and all I'm going to do is just like give everyone a little bit of space. Now, if I want to be exact about it, I could do some research and say, how big is a standard landing? I don't know, maybe it's 1.5 meters. So what I can do is I can move this 1,500 millimeters. So everything I'm doing, I'm not clicking and dragging anymore. I've got numbers in my mind. 1,500 millimeters. And that will give me a landing between here and here of 1.5 meters. Nice place to start, right? Cool. Now, it would be really useful if we could just take this line and extend it out so it touched the bottom step of the next run of stairs. So what I can do is I can use a command called extend dynamic, and that does give me a mouse to click. It basically says, you click a curve to extend, and I'm going to click the end of this one here. And then as I drag, it's basically just going to make the whole thing longer. It's just like a snake that's going to grow in whatever direction the end of that curve was pointing. It's just going to keep going in that direction. And I can keep going, and then I can snap to the end of the bottom of the next run of stairs and click again. And now I'm done, and I've got a nice landing. Cool so far? Everyone happy? Now, we're still very much in the curve world right now. So we need to start thinking about how we're going to make this solid, how we're going to make this three-dimensional. The first thing we're going to need to do is to have some kind of understanding about what this stair is made of, what's it actually built from. Maybe this is a timber stair, maybe this is a precast concrete stair. Let's start with a concrete one because it's quite easy to just make a block. You make a big block of concrete stairs, and then I'll show you how you would do the same thing in a timber style instead. Because timber and concrete, because they are different materials, they require different construction techniques. And because those different construction techniques are present, we're going to have to model them in different ways. Probably one of the things that you're finding with the objects that you're modeling on your desk is that as you start to look into them, you're understanding not just the shape that they are, but how they're made. You can see seams and you can see cracks in one particular place, or you can see how this is actually a part that just sort of clips onto this other part, or this one's screwed in, or this one's glued to that one. These are all construction techniques that actually you're understanding through modeling it. So, concrete stair over here. What I'm going to do is I know I need, basically, I'll sketch this out, I need to have a line that kind of goes underneath the stair like that. Yeah? You've seen this in concrete stairs, you see it in Abercrombie. If you look at the stairs in Abercrombie, this is what they look like. They kind of got this thickness and the steps on top that you stand on, but on the bottom side, it's just like a flat surface, like a flat concrete surface. But I'm not just going to sketch that. I'm going to get it exactly right. I want it to be a line. So I'm going to type line. Here we go. That's basically in exactly the same direction as these points on the stairs. Yeah? And then what I want to do is I want to make sure that I've got control over this distance, the distance between the thinnest part of my concrete stair and then where the back of it goes. Because if that's too thin, then this thing is going to crack. It's going to be too brittle. If it's too thick, I've used up far too much material. So I want to get that right. And I'm just going to, I've got a number in my mind. Maybe it's, I don't know, 100 millimeters or something. It's probably a bit less, maybe 75, but let's be generous. So what we can do is we can use a really helpful CAD tool, which is offset. I'm going to offset that line. I'm going to offset it 100 millimeters. Boom. So now I've got a line that's in exactly the right angle. I haven't just sketched it or made it up. It's going exactly the right angle, and it's exactly the right distance away from my steps. That means I can delete this first one because I don't need it anymore. And then it also means that I can look at this guy here, and I could say, oh, right, well, I need a line that goes on this landing. Ooh, this one here. I can move that down the same amount. Maybe it's a little bit more, actually. Maybe it's more like 125. There we go. Maybe another 25. Maybe it's 150. That feels, I mean, that's very generous. And then I'm going to do exactly the same thing here. This line and this line are going to be the same. So I don't need to draw it again. I've already got it. So I can copy it. But when I copy it, I need to be very careful about exactly where I'm copying it from and where I'm copying it to. So I can use the copy command, C-O-P-Y, copy, which I use a lot. I've set up a shortcut on my particular way of working. And I'm going to copy from the very bottom of this step, make sure I've snapped to that end. And I'm going to come up here. I'm going to go to the same place on the next run of stairs and copy it to there. So I just come down here, clicked, come up here, clicked. And then I also know that this landing and this floor might have the same kind of slab thickness. Maybe it's going to be 150. So I can offset that curve by 150. Okay, and now I've got the outlines of my staircase. I'm kind of nearly there in drawing what that section of that staircase is going to be. Except obviously my lines don't all match up. So I'm going to have to start tidying those up a little bit. One of the ways I can do that is I can come back to my extend dynamic And what I can do is I can basically extend these curves too far. I want to just go all of them. I want to go too far, please. Thank you very much. And maybe let's just match that line up to that one. There we go. And here we are. I'm going to turn my record history off. I don't really need that. That's just going to keep giving me these errors. And then there's one final curve that I haven't got yet, which is the one right at the bottom, because obviously there's a floor here, right? There's a floor that the person is walking on. There we go. And it would be really useful if the stair kind of didn't like just keep going into the floor. It needs some way of ending. It needs some way of finishing. Okay. Well, so far we're looking good. And what we could really do with as well is probably a place where this ends. I'm going to use the end of that stair like this. And we might need a bit of tidying up here. If I do extend dynamic again, just bring that back to there. Now we're in a CAD world. And there's a really cool command that you used a lot when you were doing CAD work in year one. And hopefully you've been introduced to this. Is the trim command. Give me a wave if you remember the trim command with, yeah, great. Is the trim command like your favorite tool for tidying things up? No, you hate the trim command. Well, the nice thing is the trim command in Rhino works in exactly the same way as the trim command in CAD. So all you need to do is you select a whole load of lines and you type trim and then you start tidying them. So I can take those two lines and I could trim them down, and now I've got lines that exactly meet at the right point with a couple of clicks. I can come down here, do exactly the same. Maybe I'll take all of these. I'll do some trimming. I'll go trim, 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 trim. Beautiful. And then I can trim that last one. And I need to select both of those and do trim here. There we are. And now, oh, look at that. Looking like a great staircase. I wonder whether this depth looks a bit funny. I'd be tempted to move this line up 50 mil so it doesn't look quite so silly. And then all I need to do is do some more extending and trimming. And it doesn't take long. Oh. Trim. Boop, 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 boop. There we go. Now I kind of believe that that could be a staircase. And do you see there's one bit missing, which is this line here. So probably all I'm going to do is just bring that line out to there and then draw a line that goes from here to here. There we go. And now I can select all of those lines. Now they're not currently joined together. So what I'd like to do is I want to treat this like one block of extruded material, one piece of concrete that's going to get kind of craned in and lifted into place. Probably in reality, this would be 2 bits, but let's just pretend it's one single precast element. And so what I can do with the lines is I can join all the lines together, and it's going to let me know that those 26 individual curves has been joined into one, and the most important word here is closed curve. Let's imagine that I'd missed out this little bit here. What would happen if I joined the lines then? It would say joined into one open curve. And that means it's not watertight, it's not a solid, it's not going to end up being a solid piece of geometry, which is, a single solid piece. It's going to have a big hole in it because the lines haven't been joined up. But because I have joined them up, and I've made sure that they're closed, it's a closed loop, it goes all the way around and keeps going. Now I can simply extrude that curve, and I can say, well, how wide do I want my staircase to be? Go out in the hallway, measure a staircase. Should we be really generous? Let's make it 1,500, maybe even at 1,800. So like 3 people could walk side by side up this staircase. And I could just type that number. I don't have to do it by eye. I don't have to do it by just clicking and dragging. I can just type the number. Say I want 1,800 wide, please. I press enter. And if I come into my ghosted mode, I can see that a couple of things have happened. The first is that because I had the solid option turned on, solid yes, that allows me to make sure that the ends are going to be capped. Now, by default, sometimes the solid option is turned off. And then what you get is this kind of hollow, paper-thin thing that's just the edges. And that's not what you want for a solid surface. Now, sometimes you might want that. So you're using the ability to turn that solid option on or off. And even if you messed up, let's say, oh, man, I've done this, I've done my 1800, and then you come back later and you realize that you didn't close off those gaps on the edge, close off those edges. Well, what you can do is you can tap it and type cap. And then it will cap over any straight, flat edges that it can find in your geometry. So choosing solid is kind of the same as starting with just the surface and capping it. But it's just one less thing to worry about typing in. I think this staircase is looking pretty beautiful. And so it might be nice to add a handrail, wouldn't it? Let's put a handrail in. Well, our lines are still there. And what we can do is I can come in here and hold down Control-Shift. I'll put on my key press thing here. Control-Shift. And I can click this curve here. And I can say, I want to hold down Alt and click on the up arrow. What that will do, I click once on the up arrow by holding Alt while holding Alt. What that will do is allow me to type in a number that I'm going to move that curve up, but it's also going to make a copy of it because Alt, if you remember, tapping Alt makes a copy. So I've held down Alt, I've clicked the up arrow, and I'm going to type a number. And now I need to know, well, how tall is a handrail? Well, read your building regulations. A handrail should be around 1,100 millimeters off the ground. I think these ones are a little bit low. Maybe they're 1050 or something like that. Let's say we want 1,100 millimeters from, now, interestingly, from the stair, not from the bottom of that. So now I have to add a little bit in my mind for this distance to the stair. So I'm going to call it 1,200, just for the sake of speed. And now I've got a handrail floating in the air. Nice so far. I'm going to do exactly the same here. Hold down Alt, move it up, make a copy, 1,200. Exactly the same here. Hold down Alt, make a copy, go up 1,200. And now I've got the beginnings of a really lovely handrail. This is going to look pretty good, right? What do we want the handrail to be made out of? Should we make it out of the same stuff as we've got here? This sort of steel stuff? Why don't we just use this as a precedent? So I know I'm going to have to model the handrail. I'm going to have to model those little holders that stick it to the glass. I'm going to have to model the glass and probably also the capping, that metal capping that goes on the top of the glass that stops your clothing kind of getting caught on edges of sharp glass and that kind of thing. So very quickly, we'll move on into that. This is going to be the top of the handrail. So I can select all of those. I can join them together and I can extrude that curve. And I'm going to extrude it in a particular direction. Now, it wants to extrude it left and right. That's not quite what I want. What I want to do is model that capping that's at the top of the staircase, right? The very, very top sort of edge of metal banding. Well, actually, what I want to do is I want to go in the up-down direction, not the left-right direction. So I can come over here to extrusion, click direction, and then choose a point here and choose a point there. And now this is going to allow me to extrude this metal downwards. I'm looking at that. I think that's about 25 millimeters. So I'm going to go 25 millimeters. Let's try that one more time. Extrude curve. Direction. Boop, boop. And I want to go down 25 millimeters. There we go. Much more like it. So now I've got this lovely kind of metal capping thing. And probably because I know it's going going to become useful, I'm going to put everything on its own layer. A new layer for concrete stairs. Add that to that layer. Here we go. This is just a flat surface though. Maybe I need to then offset that surface to make it solid. And I need to look at that and say, oh, that's about another 25 millimeters. So I'm going to offset it 25. And now I've got a solid piece of geometry that is modeling that top capping rail. Happy with everything I've done so far? Cool. Next, I then need to attach some glass panels to this whole thing. And the easiest way of doing that is I've got all these locations kind of basically already set. So what I'm going to do is I'm going to come in here and I'm going to draw. Now this, I know that glass panels don't come in particularly massive sizes. You'll see that they're divided bit by bit by bit. So I know that that glass panel, you can't really buy them in any more than about 2 meters, maybe 3 meters wide. So I'm going to go 1500 across and then up in a straight line until I hit the bottom of that. There we go. And then come back and close that off. There we go. So now I have this glass panel, but clearly this line here needs to come all the way up until it intersects with the bottom of my concrete. And now I've got a rectangle, I can extrude that, and I can say, oh, well, the glass itself is maybe 10 millimeters thick. And I'm going to make sure it says solid. Go 10 millimeters. There we go. Oh, let's try that one more time. 10 millimeters, solid, yes. Boom, there we go. And now, one thing we might need to have to deal with is, look, this glass is now basically completely clashing through my concrete. And that's not how glass handrails tend to be. What they tend to do instead is I'm going to select the glass, and I'm going to select the handrail, and I'm going to move it out 25 millimeters so there's a little bit of space for my handrail and my glass to kind of sit on the outside of my concrete. You see, I'm not doing any of this by eye. I've chosen the numbers, I'm typing them in. I've got complete control over everything. I've got a very, very clean output because of that. Let's do a very similar thing. We could keep going, and you could finish this off at your leisure. And maybe this comes to about here, and then up, and then up. Just going to close that curve. Yeah, there we go. Here we are. So there is another curve, and I can extrude that one, and I want to go in. Oh, I do need to flatten that curve because what's happened is, you see, this is snapped to here, and that's snapped to here. So what I need to do is I need to take this curve and project it to the C-plane, and then I'm going to move it out so it's in line with this one, and then I can extrude that curve. There we go. Boom. And make sure now that I have a glass handrail layer. Change object layer. And just to help me visualize this, I'm going to change the color of that layer so I can see that there's the glass handrail, right? And I could keep going. You've got the idea. I could just basically use the points I've already made to trace a line and then extrude it a certain distance. I could also take, hopefully, the curve. Let's take this curve, this curve, this curve, this curve, and this curve, and make a copy of them. And I'll just bring them, I'm going to do this bit by eye, you would read a book about exactly how you design handrails. And I've brought these curves down and in. I can join them together. And you'll notice something a bit odd, which is at the very end of the handrail, you have this little bit that goes down like this. And that's designed so that you don't catch your clothing on it. If you're wearing like a big coat with a big sleeve, or you've got a scarf or something, those little bits at the end of the handrail go beep, down like that. They stop you catching clothing on your handrail. That's what they're designed to do. So we might as well design that. And if we're going to be really, really fancy, what we could do is we could join these together, and we could say, instead of a really harsh line, why don't we put a nice bend in it? So I can fillet those corners just on the line itself, and I could say, let's use a 50 millimeter radius. And now it's a very small thing, but now I've got this lovely curve on the end of my handrail. And now I can come in and put a pipe in there with a 25 mil radius, and there we are, lovely metal handrail. And I'm going to say handrail, and let's color that in blue and make sure it's on the right layer. Are you following everything so far? Now we've gone from quite simple lines to quite complex structures here. I could keep going, but I want to show you a timber staircase. It's exactly the same. The only difference is that instead of being made of a single monolithic block of concrete, a timber staircase is made up of lots and lots of pieces of wood all joined together. So we need to model each one of those pieces of wood. So what we're going to do here is we are going to explode. Explode is really cool because it's the opposite of join. We joined these two lines together. We're going to explode them. And now I've got one line here and one line here. And what this allows me to do is, first of all, extrude out. We said this was 1800 millimeters. And now I can offset that, and I'll go in the other direction by clicking it. And I'll say this is 18 millimeter. I don't know, maybe it's plywood, maybe it's MDF, maybe it's solid pine, I'm not sure. But now I'm taking these lines as a starting point for building bits of wood that are all going to sort of stack up on top of one another. Are you following so far? Cool. The nice thing about timber staircases, let's head back to our drawing of a staircase. There's something called a nosing. Do you see this? It's like the stair actually carries on a little bit further than the edge. And we can model this. We can take this line, extend dynamic. I'm going to keep it going, and I'm actually going to type in, I want a 25 millimeter nosing. So I'm extending it 25 millimeters beyond where it was before. So I just type 25, press go. And here we are, and we're going to extrude that curve in this direction, please. Extrude it all the way to here. And then we're going to take that surface and we're going to offset it, and it's going to be another 18 mil surface. So now I've got two pieces of wood that look exactly like a timber staircase, a starting point of a timber staircase. And I can take these two and I can say, right, let's group them together with a group command, and let's array linear. Array linear. I know I need 10 of them to start with, so I say 10, and we'll go from here to here. I think that's right. Yes, to here. Boom. And now, here's my timber staircase, and here's my concrete staircase. Different materials, different modeling techniques, but they represent the real world. Are you happy with everything I've done so far? Any questions on that? Cool. We could make this super cool. The timber staircase, now, yeah, whether we want to do this or not, up to you. But let's copy this one up to here. with the copy command, and I'll ungroup that. And maybe this next one, slightly dangerous, but isn't going to have any risers. It's just going to be going, 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 going. So I can do array linear, and I want 10 of them, and they go between here and here. And that allows me to do a couple of nice things. So the first one is that this surface that we created on the concrete staircase, on a timber staircase, you need something to support these bits of wood. They don't just float in space. So you need what are called stringers. And they usually are found, I will copy this, that particular one. I've just done Control-Shift, and I've selected that surface, that part of that surface, and I'm going to copy it from here to here. There we go. Usually, these stringers sit on the edge, and I can offset that, and I'll go in that direction, please, and I'll make it, I don't know, 25 or something. And now what's going to happen is that piece of wood is then going to support these other bits of wood. So we clearly need 2 of them. I'm going to mirror that from the middle. And if I have my mid snap turned on, I can find the middle of any line very quickly. I can mirror it there. And now I've got one on both sides. So now I've got the beginnings of that timber staircase. I'm kind of putting it together from the bits rather than a whole block. However, thinking back to our duck thing here, I could take this and literally, I just want to use this as a bit of an experiment. I'm going to trim these bits of surface off, and then what I want to do is I want to build a stringer on this next flight that copies from here, and then actually what I'm going to do is just move that down. There we go. You could have a stringer that sits in the middle of your staircase as well as the edges. And that's what people tend to have in sort of very, very fancy high-end homes. And you have this kind of floating staircase. Now, realistically, this would probably be made of steel so that it could support the weight of these extra things. And these would also have to be made of steel because a single piece of wood would start bending and cracking if you had it that wide. So in one go, from one set of lines, we've got a concrete, a timber, and a steel staircase, all out of one process. And I haven't used my mouse to drag things. I've known exactly what I'm typing in. I'm going to pause there. Any questions on that? Next question, I'll do this in hopefully 5 minutes, and then we'll have a break, is that people tend to ask, yeah, but what if my staircase isn't straight? What if I have a windy staircase or a helical staircase, a spiral staircase? Well, luckily, Rhino's got you there too. So we're going to come over here, and I'm going to type in helix. A helix is a spiral, but it goes in 3 dimensions. It doesn't just spiral out on the flat surface. It goes up like a spring. So a helix is basically a spring. And I'm going to say, right, so I want the start of my axis for the helix to be, well, actually, I'm going to need to make some construction lines. So I'm going to come out of that command for a second. I know I need to go up. I'm going to copy this and bring it over here. I know I need to go up 3,000 millimeters. So I've got one line on the floor. I've got one line 3,000 millimeters up. And what I'm going to do is I'm going to draw a line to help me, which goes directly between the top and bottom of the staircase. So this is going to become the central axis of my spiral. This is going to become the central axis of my spiral staircase. Now, I think probably I have everything I need. Let's just double check. I can do my helix, start of axis down the bottom here, end of axis up here. Radius, start and end point. Oh, look, wow, I can make a spring. This is super cool. However, that's not very helpful for a staircase right now. There's too many turns to it. It's like a spring of a the suspension of a car or something. So instead, what I want to do is I want to come in here and see where it says turns 10. Maybe I'm going to do turns 1.5. So now I know that I can go round once, one, and then half again, and then come up to where I'm supposed to be. If I was building this, I think maybe what one turn would look like. Maybe let's think about one turn as a starting point. Here we go. And I'm going to start here, and I'm going to choose a radius of, let's think, probably about the radius of the staircase is going to be the distance that someone has to walk up it. So I need this to be a fairly decent amount of space, because the bit in the middle is going to be a super, super small slice of cheese. And the bit at the end, the stairs are going to be really, really deep. So people aren't going to want to walk there. So actually, I might want to make that something like 1200 radius. And now I've set that in place, and now I can just choose the direction I want my staircase to go in, and I'll click there once. There we go. So now I've got the outline of my helix, my spiral staircase. Here we go. I want to do exactly the same thing again, but I want to make that same thing with a far smaller radius. And that radius is going to be this middle bit here. And I'm going to do this, let's say 100. There we go. Here we are. And now what I have is the middle bit of my helix, my spiral staircase, and the outer bit of my spiral staircase. Well, we've got some cool commands that we already know, which is we can divide a curve equally, and we're going up 20 steps. We know that from the calculation that we did before. 20 steps. So I'm going to divide these into 20 segments. And now I have points equally spaced along my curve, which is nice, because what I can now do is I can grab my line tool and I can draw a line that goes between these points, a line that goes between these points, a line that goes between these points. We're basically creating some DNA. And it doesn't take long, there's only 20 of them to do. So I'm just going to kind of put some techno music on, get my head down, and draw some lines. Just going between these points, making sure my point snap is turned on so I can make sure that the lines are going exactly the right place. And we're kind of nearly there, right? Plus, because we divided both of the lines equally, each of these lines is now completely horizontal, completely flat. So we're not going to have any wonky stairs. And then this is the last stair. Look at that. Cool, hey? Pretty nice. It's like a pleasing piece of geometry. Now, this is an approach that actually up until recently I wouldn't have taken, but it is possible. I can select all the lines that I've just drawn, all these curves, and in order to make things easier for me, what I'm going to do is I'm going to put them on their own layer so I can come back and select them again when I'm done. So I haven't selected the very top one because I don't actually need it. So I'm going to make a new layer and I'll call it construction spiral stair. And I'll color it red so that we can know that it's a construction line layer. And I'm going to change the object layers to that. So now I've got all of my red curves. I can come back and I can say select objects. And it will just select all the red things. So I use layers to be like shortcuts for selecting certain sets of things very, very quickly. And now, this is the cool thing, we can revolve those lines. Revolve. Do you remember when we were making like the mug with a handle in like week 2 or 3 or something? We can revolve these lines And the revolve axis is going to be the same axis as our spiral. So I'm going to start revolve axis here, end of revolve axis here. Start angle, well, I'm going to start at the bottom of the stair, and I'm going to revolve those lines through until they hit the next stair. So I've taken these lines and I've basically scooped out a surface that involves turning it around until it hits the next step. And I can snap to the end of that line, and then when I'm happy, I'm done. Now, clearly, one of the things that's gone on with that revolve tool is that it's got a little bit confused as to where things are supposed to start and end. But that's okay, because all we need to do is select all of these surfaces that I've just created, and then just revolve them so they're in place, or rotate them so they're properly in place. And there's a really cool way of doing that, which is the only thing here that's actually useful to me is the surfaces. What I don't want to do is spend the next 5 minutes selecting each one individually and then making a mistake and selecting a line instead and being like, oh, I need to deselect the line. What I can do is use the filter, the selection filter, which for me lives over here. I'm going to say turn all of these off apart from surfaces. Turn everything else off. I don't want to select blocks or control points or lines or curves. I just want to select surfaces. And now I can only select surfaces. The filter is really, really powerful, especially when you're in that kind of position. And then I can rotate that around this point. I'm going to go from here. I'm going to rotate it until it's in line with the lines. There was something wrong with my revolve command. And now I can disable my filter and I'm back to being able to select lines and curves and points again. Happy with that? And then clearly, if I wanted to make this out of timber, I could do exactly the same thing I did before, which is I need to make some stringers. So I can do this way and this way. And then all of these surfaces are then kind of ripe and ready for us to offset and to make them solid so that we can actually build something out of them. Happy with that as an approach? Is it easier than you thought to make really, really curvy, silly staircases? Now, challenge for you, how might you do a staircase where there was a straight bit and then the next bit was maybe like half a curve in one direction and then maybe it comes round and goes the other direction. All sorts of fun things you can do with stairs, where it puts your modeling skills to the test. Take 10 minutes, put some questions in the Mentimeter. I'll leave it open, and then we'll come back and see if I can cover as much as I can in the last 40 minutes or so. Happy? Great.